Hi guys, and welcome back to part 2 of this video. Trying and keep this one a little shorter than the last. So it's a continuation. It's quite a big, as you can see, these questions are quite big in size, and so it's hard to keep it all into one video. So we're going to sort of carry on where we left off. The last question was where we're looking at this set of data, and now in this question there's actually a third data set. So in this paper it says the OSG1 gene causes long day flowering, and the effect of its overexpression has been observed in a transgenic variety of rice. Some wild type rice, WT, and transgenic plants were exposed to long days, 14 hours of light per day, and others to short days, 9 hours of light per day. The shades of grey in the graph represent the genotypes of the transgenic plants, where minus do not have the overexpressed OSG1 gene, plus minus are heterozygous for the overexpressed OSGI gene, and plus are homozygous for the overexpressed OSGI gene. So let's just have another close look at the stem of the question, or the stem of the transgenic simply means genetically modified. Okay, wild type are the non-genetically modified. And then they've just been, each one's been placed under short daylight and long daylight. Long day being 14 hours of light per day, and short day 9 hours per day. And what they're measuring in this graph is the time before, the time of the plant before it flowers, or the number of days before it flowers. So you can see in short daylight, the wild type flowered within something like 62 days, so maybe that's 64 days, sorry, and the wild type in the long daylight took 82 days, so longer period. All right, so let's have a look at some of the questions. Question E1 states the overall effect of overexpression of the OSGI gene in plants treated with short daylight. Now, state, again, as a pretty simple command term, only worthwhile mark, give a specific name, value, or brief answer without explanation or calculation. So let's have a look at the effect of overexpression of the OSGI gene in plants treated with short daylight. So that's here. So you can see this doesn't have the overexpression of the OSGI gene. Okay. This one also does not, and these ones do. So, well, this one is heterozygous, this is homozygous for the OSGI gene. So you can see what the effect is, okay? The presence of the overexpression of the OSGI gene is causing an increase in the length of time before flowering, okay? And so that's simply the answer that you need to make there. Compare the results between the plants treated with short daylight and the plants treated with long daylight. Again, compare, not an easy one. Give an account of similarities and differences. Remember, it's the similarities and the differences between the two samples. Okay? So, what are our differences and what are our similarities? So, hopefully you'll see that long daylight exposure increases the time before flowering only if OSGI gene is not overexpressed, i.e. in WT and the minus, the negative do not have the overexpressed gene, transgenic. So these ones, look, have actually long daylight exposure increases the time for flowering for these guys. Okay? In the same way, long daylight exposure decreases the time of flowering for the homozygous and the heterozygous overexpressed OSGI gene transgenic plants, these guys. So you can see these guys have gone down and these guys have gone up. Okay, so they're almost the opposite. You could also mention that the length of day does not make much difference for the homozygous, so that's only decreased by a small amount. Probably that's the least amount of all of them. Question 3. State giving one reason taken from the data opposite if unmodified rice is a short day plant or a long day plant. So when we say unmodified rice, we're obviously looking at the wild type. So we want to determine whether it is a short day plant or a long day plant. So basically, how do we know if it's a short day or a long day? What it means is it takes less time for it before flowering. So find the one which has the shortest period before flowering. And so hopefully you can see here before flowering it's 62, here it's 82, or 84, sorry. So obviously, hopefully from that you can deduce that it is a short day plant because it has the shortest time before flowering. Okay, last question we're going to be looking at. Evaluate using all the data how modified varieties of rice could be used to overcome food shortages in some countries. So it's only worth 2 marks and you've got 3 data sets. So you can basically choose any of your data from any of those 2 places, okay? So evaluate. It's a tough one, okay, because of what does evaluate mean? It's one of our higher order thinking skills. And it means assess the implications and limitations. Okay, so you've got to assess the implications and limitations using all the data, how modified varieties of rice could be used to overcome food shortages in some countries. So, if we look at our first data source, right back over here, okay, well, we can say that the mutant GID11 would not be useful because it's producing sterile plants, okay? So it's producing sterile, so that is not going to prove useful. So the wild type is much better suited than the mutant GID11 type, okay? That's one clear point you can make from that data set. The second key point you might want to make, okay, is that genetically modified rice that has a sub1A gene is more tolerant to submersion and can withstand seasonal flooding. That's the second point you might like to make, okay? And the third argument you might like to make, using the third data, is that OSG1 varieties, okay, so that's our transgenic, so RSGI plus varieties, the ones that are heterozygous and homozygous, are adapted to different latitudes. And so what that means is that if you can modify day length, you can reduce the amount of time before flowering. And obviously if you flower quicker, you reproduce seeds more quickly, and which means ultimately you get more growth. So OSGI plus varieties are adapted to different latitudes, and day length different day lengths can be produced to overcome food shortages. All right, that's the end of that question.